Beyond the plaster, the paint, and the AC vents, you are sitting right underneath the total unsung workhorse of structural engineering, the slab. Welcome to this explainer where we're going to unpack the hidden engineering choices that literally dictate the safety, scale, and shape of our entire built environment.
But that brings us to the big central engineering question, right? Which slab is actually used in which building? The answer to that question dictates exactly how we build, scaling all the way from the tightest little residential corridors up to the most massive architectural monuments.
All right, let's start with the basics. The scale of small spaces, one-way and two-way slabs.
These guys are the absolute bread and butter of our everyday spaces. A one-way slab is supported on just two opposite sides, kind of like a simple bridge. But a two-way slab, that one is fully anchored. It's supported on all four sides by walls or big load-bearing beams.
And that setup completely changes the physics of the whole shebang. You see, the one-way slab transfers its load, the dead weight of the heavy concrete plus the live load of us and our furniture, in just one single direction toward its two supports. But the two-way slab, since it's anchored everywhere, safely pushes all that weight outwards in both directions.
Because of that one-directional load transfer, the one-way slab is practically custom-built for long, narrow spaces. Think small rooms, tight corridors, or that narrow veranda outside. The two-way slab, though, with its ability to distribute weight across four sides, it safely covers much larger, square footprints. That's exactly why two-way slabs are the go-to for giant halls, wide-open office floors, and multi-story commercial buildings. Moving on to our next scale, scaling up, the massive spans of waffle slabs.
Now, a waffle slab is, well, exactly what it sounds like. It's a ribbed slab with this really distinct grid pattern on its underside. But it's definitely not just to look cool. That deep grid gives the structure immense stiffness while stripping away tons of unnecessary concrete. It literally sheds dead weight compared to a regular solid flat slab of the exact same thickness.
So, when engineers are looking at a design that needs a sweeping roof, and absolutely no one wants a forest of columns ruining the view, waffle slabs are the total heroes. They effortlessly clear these massive spans in sprawling airport terminals, huge auditoriums, and commercial halls, where unobstructed sightlines are absolutely crucial.
Next up, we're going vertical, building towards the sky, factory-made precast slabs.
Look, hauling thousands of tons of wet concrete hundreds of feet into the air is mathematically and logistically a nightmare. So engineers pivot to precast slabs. These are manufactured off-site in a highly controlled factory environment. And crucially, they're cast with hollow cores inside. That hollow space drastically cuts down the weight without sacrificing any of the structural integrity.
They arrive at the construction site fully cured and basically lock into place like massive structural Legos. It's pretty awesome. This efficiency makes them the backbone of modern high-rises and dedicated precast structures, essentially turning skyscraper construction into an incredibly fast vertical assembly line.
Finally, we reach the grandest scale of all, the pinnacle of design, special architecture, and dome slabs.
Breaking away from boring flat planes entirely, the dome slab utilizes a structurally curved geometry, and calculating the load transfer of a perfect hemisphere is wild. It requires some truly masterful engineering, so the heavy materials support themselves in compression and drive all that weight safely down into the surrounding walls. Because forming them is incredibly difficult and, frankly, super expensive, dome slabs are reserved for very specific, special structures. We're talking grand temples and highly specialized architectural monuments, places where the whole point is to draw your eyes upward and inspire some real awe. All right, let's pull this whole thing together with a quick cheat sheet. The one-way slab pushes loads in one direction for tight rooms. The two-way pushes outward in all directions for wide offices. The waffle slab clears those massive airport spans with its ribbed grid. Precast hollow slabs efficiently stack up our high-rises, and those beautiful curved dome slabs crown our majestic monuments. From small verandas to grand temples, the right slab dictates the strength of our world. I just love that thought. Every single structure we inhabit quietly relies on one of these totally distinct engineering choices to safely support our daily lives.
So next time you walk down a tight corridor, or step into a massive airport terminal, or look up inside a beautifully curved architectural wonder, will you actually know what's holding up the ceiling above you? Keep your eyes open, keep analyzing the spaces around you, and I promise you'll start seeing this hidden engineering magic everywhere you go. Thanks so much for joining me for this explainer.